Hi, everyone. Thanks so much for joining us today. My name's Jenna, and I'm joined today with the founder and owner of SFPWorx, Mark Simpson. Thanks so much for joining us. So Mark, obviously this is a huge and growing industry, and we've spoken about it a lot, how we wanted to create a guide that would make it easy for people to try and understand optics, which is a very complex topic. So of course, today we're not going to go into too much depth, but we would just like to make sure that people who aren't proficient in the language of optical transceivers feel a bit more confident. So I'm going to just share my screen. Right, so basically how this is going to work is we've created a cheat sheet which is available for download in the Zoom chat. And we're just basically going to show you how to use it. It looks like this. And if you stick around till the end, we'll do a practice session when you can make sure that you actually understand how we've laid it out and how you'll potentially use it in the future. So without further ado, Mark, let's have a look at a scenario that we've experienced a couple times, and basically how we would approach this. So customer one wants to upgrade their whole campus network infrastructure from 1 gig SFPs to 10 gig SFPs. Currently, the uplinks are running multi-mode fiber on OM3, and the approximate distance of the 20 uplink connections vary in distance from 100 meters to 550 meters. So now this customer has actually said to us, will it be able to run 10 gigs over that same distance? And what answer would you give that customer?
Jen, thank you for that great introduction. More importantly, thanks the audience and all the people attending the webinar that are being part of this. Great, thank you. The most important question here would be, I think this happens quite often, that a lot of customers have an installed base. They have a site that's in production and is delivering services. Network companies go in and say, let's upgrade to 10 gig connections for the users. They put in a lot of wireless, etc. And then what they don't look at is the current cable fiber plant, which is running multi-mode in this instance, which is a very important question. And I think where people go wrong here is that multi-mode fiber, when you're running 1 gig, can run up until 550 meters. Now, when you're trying to put 10 times more data, so 10 gigs of data down that same fiber connection, unfortunately, it doesn't run 550 meters. It only runs 300 meters. So customer will say, well, network engineer, network architect, you told me that this environment's going to work. And what the customer's going to do is there's a choice they need to make. So let's say of those 10 connections, uplinks, 5 of them are less than 300 meters. Those 5 will work at 10 gig, but the other 5 are not going to work at 550 meters. So they have 2 choices. The one choice is to keep the 1 gig, and that's going to be a reputation loss because you're saying, why are we going to run 10 gig switches and we can't run at 10 gig? The other issue would be that they'd have to upgrade to single mode fiber in order to make those that connection work. And then there'd also be additional cost that if they move to single mode fiber, they'd have to change the optical fiber transceivers. And the optical fiber transceivers between multi-mode and single mode, there's maybe a cost differential of 25%. So, and the same customer would have to, if it's a large industrial site, would have to lay new fiber, which probably is going to be almost an impossible task if it's not planned, and depending if it's a live environmental site, it might not be that easy to do the upgrade. So that's one of the common things that I see in the game, that when people try and upgrade network infrastructures or campus networks or big industrial sites.
Okay, so I think a lot of people, they know multi-mode fiber, they know single mode fiber, but I don't know if they understand the science behind it, which is why we get asked this question so often. So I just wanted to know if you could maybe go into more detail about how single mode and multi-mode work.
Okay, so in this slide or this presentation material, I'm giving a view of all the different fibers that you have. And I think it's very imperative and more important to say that if you look at the bottom right of the screen, that's a hair follicle, which is 40 micrometers. So if you think about a hair, a single mode fiber, which is on the far right, the strand in the middle of the clad-in, so the clad-in is that white area that protects it. The diameter of that is 9 micrometers. That's a tenth or half of a hair. Okay. Now, single mode fiber, as it stands, and from a technology perspective, there's no other fiber optic that's going to be created. Maybe I can't say that, but single mode AS2 single mode fiber is at its peak. They can't improve it from a technology perspective. So that's the fiber that we're going to have to deal with moving forward. Now, you all know, with the proliferation of Facebook and everybody connecting and the fat pipes that everybody wants to connect, single mode fiber is the medium of choice. But also realize that single mode fiber has a cost associated to it. The transceivers are more pricey than multimode. I'm now going to touch on the multimode side. So multimode in its infancy ran at 62.5. That's the diameter of the fiber. If you think about it, and I draw an analogy, if you had to shine a torch through the big aperture, it would bounce off and refract. So obviously, OM2 or multimode fiber that torch wouldn't shine through too long because it's refracting, as opposed to a smaller diameter like the single mode, where you shine a light or laser through, will not disperse and break down.
You don't do much light, right? It's more pinpoint.
So what is important is that on the multimode side, existing environments used to be fibered with OM2. New modern sites would be fibered with OM3. And there's also a grade of multimode fiber, which is OM4. I think it's quite important and pertinent to bring in a transceiver that runs on multimode fiber, is a short range transceiver. And it's made as a cost-effective option for shorter lengths. Obviously, single mode fiber is, if you look at without a signal being amplified with any active equalization, you can run a connection on 1 gig up to 120 Ks. On 10 gigs, you can get 80 Ks. On 100 gigs, you can get 80 Ks. This is without any amplification and any dispersion compensation, all that technical jargon that makes that signal go further.
Okay, very interesting. So, I mean, we've covered the single mode and the multi-mode actual fibers, but what about the connectors? I think that's also pretty important.
Yeah, so the most important thing is that when people choose transceivers, and this leads on to why I've created this cheat sheet, is that there are certain building blocks that you need to look at. So if we look at, and this is, I'm talking about a environment that you'd be designing today with the fiber, and I'll touch on legacy implementations and why we need to understand the legacy implementations later on in the webinar. But there's two types of fiber that you look at, and these are the patch leads. So LC is a common connector. Most optical transceivers that are manufactured today or are current have an LC connector. So there's two LC fly leads and connectors at the top. If you're going to get a single mode fiber optic fly lead, it's going to be yellow. If you are going to get a multi-mode fiber optic fly lead, it's going to be the right, which is aqua, that's OM3. Understand that the connectors are the same, so they don't vary. The differences are the fiber, which are covered, the diameter of the fiber and the distance it can cover. What's very pertinent is that now we go to the next level of connectors and patch leads. In order to get further distances, when I say speeds of 40 gig or 100 gig, what a lot of technology people have done, and I'm going into a bit of detail about an optical transceiver, is that they create 4 lanes. So in order to get 40, they had to aggregate or multiplex 4 by 10. So you've got 4 lasers and receivers in the fiber. So that MPO connector is actually running parallel fiber. So within that one lead, you actually have 4 transmit and receive fibers running across it from point A to point B. Now, if you had to extrapolate that and put that, if you wanted to run that in your campus, you would have to have 8 or 4 fiber pairs from point A to point B. That example that I gave you running 10 gig, they only had 1 fiber pair. So they wouldn't be able to run 100 meters. And the distance limitation on 40 gig and 100 gig is 100 meters on 40 gig and 150 meters on 40 gig and 100 meters on 100 gig. What is very pertinent is that the other connector that optical transceivers are, or pluggables are UTP, and that's the bottom picture where we have Cat5 unshielded twisted pair. We have 6A and 7. On the 1 gig optical transceivers, so when I say optical, it's a copper, so the media is copper, we can run up to 100 meters. When you run 10 G base, unshielded twisted pair, you need to run on 6A or 7, and the distance that you can run on that is only 30 meters. So that's also what a lot of people oversee. They think it can run the 100 meters. It can't. It can only run 30. The other caveat is that this optical transceiver runs very hot because of what it's trying to do. When I say hot, it draws a lot of power from the switch, and some switches do not support. You can't populate the full switch with, say, it's a 24-port SFP plus switch. You can't put 24 ports of 10 gig in it. You've got to do it in pairs, in groups of 4, because the switch doesn't have the wattage to drive those optics.
Okay, that's interesting. So then maybe let's go a little bit into more detail about coppers and also tie in AG cables. Those are also getting pretty popular, at least at SFPWorx. So yes, what's some more information about that?
Very good question, Jen. I think what's important is that you've got to pick your copper or fiber cable for the implementation. So talking around DACs and ACs, typically in a data center build, you would use DAC cables, and a data center build, when I'm talking about a data center build, I'm going to get a bit techie, is we got to connect a data center switch to our servers, which are the compute nodes. That's the stuff that does all the work and that does the Facebook delivery and the databases, etc. And in the rack, so you'd have a 52U rack. You've got a distance limitation of 1, 2, 3, 5 meters to run 10 gigs. That distance becomes less when you run 100 on a DAC. I think a good way to explain the DAC is it's got pre-terminated, so it looks like optical transceivers that can be changed, but it's not. They're pre-terminated. They're not active. They don't draw lots of wattage like the 10G base T optic the pluggable optic that I spoke about. Now, the issue is the distance limitation. So you can only run 1, 2, 3, 5, up to 5 meters. So the active optical cable, same thing, it's running on multi-mode fiber. It's pre-terminated. You can't change that fiber patch lead. And one of the caveats with regards to that is if you are doing a data center build, and let's say you're moving from one rack to the next, and you want to extend the distance of the active optical cable, you want to extend it from, let's say, 5 to 10, you can't. You need to extend it by buying another another active optical cable. Or alternatively, an option would be to go for 2 active standalone transceivers running at 10 gig or 25 gig, and then you can connect the 2 of those together. One of the other disadvantages of DAC is that they take up a lot of space. So UTP Cat5 fly lead is quite small. When you look at these DAC cables running 100 gig or 400 gig, they're quite large.
Like that picture.
Yeah, this is now the average person looking at this is going to say, well, this doesn't look tidy. I would say that I would give this a rating of tidiness, 95%. It's not the best I've seen, but it's definitely not the worst. And there's two iterations here of what I wanted to explain. Look at the bulkiness of this cable. Okay, you'll see that there is UTP, which is the yellow flyer leads in the middle. Then you've got orange, which is the active optical cables. And typically the active optical cable would be connecting this rack to another rack, which is probably 100 meters away, between 5 and 100 meters away. And that would be one of the building blocks that you would use when you build a data center connecting to your storage, et cetera, et cetera, et cetera.
Okay, very interesting. So, I mean, that's the one part with DAC and AX. I mean, I've heard you mention quite a few negative points. I mean, why would you recommend them then?
Okay, so one of the only reasons why people go, and it all boils down to cost. The DAC cable is the most cost-effective option of connecting devices, so data center switches to your compute nodes at a short distance. But now you can see that, look at how bulky the cable management of this. Imagine if you had to change one of those DACs, or one of those DACs goes faulty. If one side of the DAC goes faulty, guess what you need to do? You've got to change the whole DAC, so that wherever that cable starts from and ends, you need to take it out of the cable management to replace it if it goes faulty. The other caveat is, look at, if you're looking at a data center, you have a cold aisle and you have a hot aisle. How is air going to cool all your equipment when you look at the bulkiness of this cable? Okay. So what I sometimes recommend for fiber for connectivity is the AOX, because they're a lot smaller. So if you look at the orange connectivity there, they are a lot smaller diameter, and it allows for cooling. The other option, and sometimes people will do this, is they will use active optics between the compute and the data center switch. And then the fiber patch leads, if you had to move this data center, which often doesn't happen, but sometimes it may, you just have to change the length of the fiber. So okay. There's different options of how you can migrate and move forward.
We have a question mark about the cables. Why is there perception that these CAT cables can run 100 meters?
So just like the fiber distances, there's a reach for UTP. Mm-hmm. So UTP on 1,000 base T can run 100 meters. On 10 gig, okay, it can only run 30 meters. There is a new technology that Cisco's produced, which is the multi-speed port, and they pushing longer distances, but it's not. What that means is that your current cabling plant would have to be replaced in order to run those speeds. What those new switches do, and I talk Cisco because I know Cisco fairly well, is that it will negotiate the maximum speed across that connection, and it may not negotiate 10. It might step down to 865 for longer distances. So that's called a multi-speed port. Very, very new technology. Lots of people. If you're looking at future-proofing your network and you did a brand new campus design, you would probably sell those switches. Because of the multi-switch up.
Just how we've done, asking the right questions are absolutely essential when trying to plan a build like this or prepare a solution. So I think there is a very important part of this presentation is being able to ask the right questions. So what are the questions that people should be asking, in order to select the right optical transceiver, so there aren't any issues like this that'll happen in the future, like we saw in scenario 1.
Okay, very good question, and one of probably the most difficult questions to ask, because it's always an oversight when people put designs together, or possibly the integrators don't, the customer doesn't really know the detail of what's connected and what the lengths are, etc. So the most important side is, typically when we have a piece of fiber, it connects a piece of network kit from network A to network B. So what is the network and vendor kit that it's going into? So side A, is it a Cisco that's connecting to a Fortinet firewall, which is side B? Very, very important question. Now, what's the distance? So realize I'm just talking about fiber here, and I'm talking, technically speaking, I'm talking about a cross connect that would be at a data center, and it is a fiber run because it's over the 100-meter distance. You would have to know what the type of fiber that is installed from point A to point B, and the distance. And that's very important to understand the distance that we're running, because different optical transceivers have certain riches, and that's a standard. And that standard determines the optical transceiver that we choose, and that will be discussed when we look at the cheat sheet or the quick product reference guide. So those are the two questions that are very pertinent. Now, all of a sudden, we have to ask a third question. What is the speed, okay, the data rate that we want to connect that said switch or firewall or router to the other side? What are the data rates that you need? Now, what's important is to understand that we all would love to sell brand new stuff and the latest and greatest, which has all the latest technology, but we do have legacy environments, and most networks that I form part of or put recommendations together, everybody has a legacy. So the key is you've got to ask these right questions. So the compatibility is also a big issue, because I'm not sure if you know that when you have Cisco equivalent optics or you have Aruba equivalent optics, there's a piece of code that the vendor has put in their switch to make sure that the optic is compatible. So what we can do at SFPWorx is we have the method of programming those EEPROMs, so we can make that cable work or that transceiver work in the different platforms. Those are quite a few of the caveats. I think the most important question is to know what is being connected to what's the type of networking kit, what's the media you're going to use across the network kit, and the speed. You can't run a 1 gig, you can't connect a 1 gig service to a 10 gig optic and vice versa. And typically speaking, in most cross-connected data centers, at one of the biggest hosted data centers like Terrico, where a lot of people will have services, the fiber is always single mode fiber. So I'm not sure if that answered that question.
It does. I think one of the points there that you mentioned, we can go into a bit more detail, and that's the form factor.
Okay. So this is a very busy slide. Okay, and the reason why I wanted to bring this up is because if you look at when the first optical transceiver was developed, it was in 1995. We're now in 2023. That was 28 years ago, 27 years ago. So these form factors have changed. So we then go in 2000, which is SFP. So SFP runs the speed of, and you look at the left of the graph and you see that's the speed, and you look at the bottom part of the graph and what the year it was that technology came out. So the key here, and it's the most important thing, is that there are different form factors. So let's say that you have a customer that's invested a lot in Cisco ASR routers. That's a big high-end router. Don't assume that the form factor that one of the line cards in that router has is going to be SFP plus when it connects at 10 gig. It might be XFP, which was developed in 2005. So what the slide is saying is different form factors were based on production cycles and technology, as well as the development of the optical transceiver. So let's have a look and go faster. So everybody wants to go faster in Ethernet, and I think this is quite pertinent. The Ethernet Alliance is an alliance that's formed by multi-vendors, and it's their 50th year anniversary. So Ethernet's been around for 50 years this year. A very pertinent question. So Ethernet is a technology that's been around, and all these optical transceivers, lo and behold, run Ethernet connectivity. Now, if we look at 2020 and we look at the new emerging technologies, and I need to state this, that my cheat sheet goes to 100 gig. When we get to 400 gig and 800 gig form factors, this game becomes very complex. Okay, the rationale behind that, and it's very important, is that the optical transceivers are now, because we're trying to push more information across the same fiber. I mentioned to you that single mode fiber is not going to be, there's no new fiber that's going to come out. All the technology now resides on the optical transceiver. What does that mean? Okay, that means that more can go wrong in the optical transceiver. What am I stating? Make sure that you choose the right, if you're looking at third-party equivalent optics, choose the right party to deal with regards to the quality, and more importantly, their guidance and their view of what that optical transceiver is. So lots of people state that they can sell optical transceivers. I think the most important part, and this is a sales pitch, make sure that the person that you're buying that optical transceiver from, if it's a third-party equivalent, understands that quality statement, because the faster you go, the more that can go wrong. And the more that's on a transceiver, the more likely that it may fail. But understand that that's technology. The faster you go, there could be some risks regarding the optical transceivers. I think what's important is that the technology is there, and we look, there's different technology choices when you go faster. But I'm ring fencing this cheat sheet at 100 gig. In South African terms, there's not many people that have gone to 400 gig. There's not many people that have gone to 800 gig. And there's not many people in South Africa that have gone to 1.6 terabytes, which is the latest speed that developments are in transceiver space.
Okay. All right. So I think we can put our cheat sheet to the test, and if anyone who's watching would like to participate, there will be a poll. So it'll come up on the screen and you can select the answer that you think is correct. And this is the real world case study that we're going to be using today. And then I do invite you to either download the cheat sheet, which is in the Zoom chat, or you can, I'll pop it up on the screen as well, and you can use that. Also, if the poll comes up on your screen, you can just move it so that you can read what you need to read on the screen. Okay, so the real world case study that we have here is service provider's POP, the point of presence, is 25 kilometers away from the customer. DFA, or Dark Fiber Africa, has a fiber service in that area. What optical transceiver would you choose for your customer if it runs at, and the first question is if it runs at 1 gig. So we invite you to use the cheat sheet. You can just have a look, move my poll. All right, and we'll give you a few minutes to just try and work out which one you'll be picking. Okay. I'll just switch over to the question in case you can't see. All right, Mark, would you like to explain the answer that we have here?
Okay. Well, the question, first and foremost, is we look at, so if you look at this cheat, and I think it's probably a great time to explain it. Going down the left side of the columns, okay, is the speed. So as you go from the top to the bottom, it gets faster, faster, faster. And the other criteria is the reach. So if you look at that question, what's the reach that we're looking at? So at 1 gig, 10's not going to cut it because it's too short. 40 is going to cut it, but it's 30, which is cool. So at the 1 gig service, the answer would be 1,000 base EX.
All right. So on the poll, 50% of people said SX and 50% of the people said EX. So why is it not an SX for the people that did select that one?
Okay, very good question. Because the SX can only run 550 meters. So that's the reach. So you're looking at, it's got to be run across single mode fiber. Maybe a very difficult question, because lots of people maybe don't connect sites at 30 Ks away, but that was part of the reason.
Yeah, it's true. I mean, it happens, right?
Yeah.
So you need to be prepared for any of these scenarios. Okay, and if we go back and we have a look at the second option, which is, again, the same point, it's 25 kilometers away from the customer. However, we now want to run it at 10 gigs. So 25 kilometers at 10 gigs, it'll have a look. The poll will be put up for option 2. And you can select the answer that you think is correct. So yeah, it is a bit of a trick question, especially because it's 25 kilometers away. Okay. All right, so Mark, do you want to go through the answer for the second option?
Okay, so obviously we're looking at 25 Ks. We now go into the data rate's going to be 10 gigs. So there's a whole bunch of columns under 10 gig. Oh, sorry, rows. Which one does the 10K one cut it? No, because it's too short. Does the 40K one cut it? Yes, because it can run between 10 and 30 Ks and 40 Ks. What's very pertinent about the reach, and this is important for me to bring it up, is that in real world environments, that 40K or that 25K connection, okay, has a lot of splices in it, because nobody can lay a fiber 25 Ks from one point to the other. There's going to be lots of splices where people are going to connect it. So there'll be a loss. So when we talk about 40K reach, that's the theoretical distance, but it's safe to go down maybe 5% on that figure, or 10 to play it safe. Because we don't know what the quality of that fiber is. We don't know how many splices there are. And Dark Fiber Africa would generate a report and say that this fiber from point A to point B has an XYZ, so a 16 dB loss, because 40 Ks would be a 16 dB loss. If that fiber is 14, then it would be able to run the 25 Ks, or probably 35 K. So don't use it at the extreme, because this is a point-to-point connection, and no fiber I know it's got no splices for 25K. It's got multiples.
So just on the poll, you'll be happy to know that 60% of people gave the correct answer, the 10 base ER. 10% said Alex and 30% said LR. So that was a good answer for everyone who participated. But yes, we'd like to invite anyone to ask further questions. I do have one question here for you, Mark. It's going back to the DAC questions, the DAC cables. How does the quality of the DAC cable impact the overall performance and reliability of the network?
Yeah, that's a very good question. Okay. And I always bring up the quality statement. So very important. Everybody says that they make DAC cables, and the quality statement is that they need to be tested. I think the more important pertinent answer to that question is that the DAC cable is graded with different, so a DAC cable is really twin-ax, and twin-ax is sort of, I don't know if people know, that satellite cable that you're running your DSTV is very similar to twin-ax cable that runs between two DACs. The quality of that cable increases when you want to run faster speeds. The one important thing about DAC cables is that it doesn't use power from the switch. It's probably the most power efficient. So the one positive about DAC cables is the most power efficient use of the SFP tray or the pluggable SFP port on the switch. And if it's not active, one would say, well, then it's probably marginally faster. And that answer is yes, but it's such a small variance that nobody would see the difference. So it's a great question.
Okay. Okay, well, unless there are any other questions, yeah, I think we can wrap it up there. Unless there's any other final statements that you would like to make.
Yes, I would. Thank you. Thank you to the audience for participating, number 1 and 2 in the webinar. I think what's very pertinent is that as we move into the faster speeds and feeds with regards to optical transceivers, this cheat sheet doesn't help, because it's a bit of a nightmare when you're going 400 gig and you're going 800 gig. Obviously, that's going to hit us maybe in 2 or 3 years. Also realize, and I think I need to do this in closing, is that the big data scale, the big hyperscale data centers in America or the Far East are running 1.6 terabytes connectivity between point A and point B. So that's the Facebooks of this world, the Amazon Web Services. I think this is actually where the development goes. The smaller players like the Ciscos and the Arubas of this world get dictated by the big web scalers, because that's all where the research development for all the optical transceiver developments are. Because, you know, technical people, they want the fastest and the greatest and the fastest optical transceivers. So that's my statement. I think what's also very important is that there's a whole nother discussion when you want to run faster speeds over that single mode fiber, which would be a great topic for a future webinar, where if you're spending a lot of money between point A and point B, like a 40K fiber from dark fiber Africa will probably cost you 100,000 Rand a month.
Yeah.
Wouldn't you want to push more data across it? Yes, there's technologies like DWDM, CWDM, which could leverage that fiber with multiple channels. But I think that's a good topic for another webinar, and it's a bit more of a deep dive with transceivers. But thank you once again.
But it's upcoming technology, right? So it is something that's important that we will inevitably need to learn about. So
100%, because bandwidth requirements, as we all know, they incrementally grow every year. So the bandwidth, everybody needs to go faster, and everybody wants to consume all these great services. And when I say services, Facebook's the younger generation, very similar to your age, likes Facebook, Instagram, don't have a concept of what's happening in the back end and what the speed of the optical transceiver is. Thank you.
Okay, well, thank you very much, Mark. Thank you for everyone, to everyone that joined us today. And we look forward to a future webinar on, I don't know, the future of optical transceivers. Wonderful. Thanks, everyone.
Thank you. Thanks.